Hi, welcome to Root Causes. We are very excited to have our return guest, Bas Westerbaan of Cloudflare. Bas, I forget your specific title, but you're basically a career cryptographer working for Cloudflare, and you have been a pioneer and a champion in the world of practical post-quantum cryptography for the WebPKI and our own networks, and a pioneer and a champion for Merkle Tree Certificates. You're the first person I ever heard that concept from when you were on stage at a PQC conference in 2023. So you're where I learned of the idea. So with that, we were hoping today with our listeners, we could hear from the horse's mouth, what are Merkle Tree Certificates and why do we need them? So where do you want to start?
Well, let's start with great to be here again. This is
Thank you.
Fifth? I lost count.
I lost count. Yes.
Great to be here. Yeah. So Merkle Tree Certificates, it solves the big problem of signatures are large. Signatures are large, which means it's big, and it doesn't always matter, right? If you watch a video, it doesn't really matter that much. But what we see on the web is that more than half of all connections transfer less than 8 kilobytes from server to client. And if you would do PQ, you would just double that. You would just be sending certificates. That's it, right? Half of our connections would just be 3/4 certificates, which is crazy. And that has a performance impact. And we want it to enable post-quantum by default. That's what we want. We want post-quantum on by default for everyone. And that means that no one should be able to complain about the impact of it. So we need it to be fast enough. So that's the reason why we started thinking about Merkle Tree Certificates quite a few years back already, to see how we can do this without losing performance.
So why? So the signatures don't get any smaller in the MTC scheme. So how is it that it fits in the available space?
Yeah. So the trick here is that over the years, because signatures were cheap, if there was a problem, we'd fix it with a signature, right? We want to have a delegate trust. We add an intermediate. We want to show that something is not revoked. We add an OCSP staple. That's another signature. We want certificate transparency. How do we know it's actually locked? Well, let's add just 2 other signatures, right? Anytime we have a problem, we plop on a signature. And that used to be the go-to solution. But that's not that cheap anymore. So now we have to think of a different way to solve the same problem.
And what's that way? Go ahead, Jay.
So Bas, my understanding is now we're only signing once, right? We're signing the root of the tree. Now that's probably an oversimplification, but it seems to be the way that you're solving it.
Yeah, so the trick is that nothing comes for free, and that's one thing. We sign the root, so we summarize. Instead of signing each certificate once, we put all the certificates we have in a larger and larger and larger tree, just like certificate transparency, and we sign the tree heads. So that means that you have to sign a lot less, but there's still a signature. But then there's the second trick, which is that modern browsers and modern clients, they are not static. They're updatable. They get information. They have a way where they can learn about revoked certificates. Browsers, they have a mechanism where if there's a revocation event, the browser can push to all their clients, look, this is revoked now. Like this mechanism is important, that it's quick, so you can get it. But you can use that same mechanism actually not just for distrusts, but in a way also for trusts, where the trick is here is that you have this ever-growing tree, where each of the certificates you add in this tree, without the signatures in it itself. Right? This Merkle tree, the certificates at the bottom. We call them certificates because that's like the mental model. There's no signatures in there. There's just the assertion that says this domain you can trust with this public key. That's the only thing. This ever-growing tree, and every time a CA signs that tree, it's like I certify that all of these certificates at the bottom, they are correct. And then once in a while, once every say every hour, we pick a tree size, a landmark. We say this is a special tree, it's a landmark, and every hour we have a landmark. And what we do is that we push those landmarks one every hour, so just a small hash, 32 bytes, we send to the browser or to the client. Then if a browser wants to connect to a server, it can tell the server, I have got these landmarks, and then instead of sending a certificate with a bunch of signatures, they only send the inclusion proof to show that that certificate is actually in the tree. And the only thing that they have to send then is, well, the certificate itself and the proof that it's in the tree. And this proof that it's in the tree, that's called a Merkle Tree authentication path. That's not that long. It's maybe 700 bytes if everyone would use Merkle Tree certificates.
Bas, this is my question about landmarks, because when I was first studying the concept when you came out, I guess this was also used as a means to be able to have not just batched certificates, but also one-off real-time certificates. This is one of the properties of a Merkle Tree certificate scheme that I was always interested in.
I'm not quite following. Can you?
Yeah. So, in other words, one of the early issues when Merkle Tree certificates as a concept was first coming out was the idea that you needed to basically, because of the fact that the certificates were issued as a batch, the idea of a real-time certificate was difficult. But then you came up with the solution for it. And part of that was the landmark concept. Am I right in saying that?
Yeah. So so this is the second iteration of the Merkle Tree certificates. In the first one, we really had it like a batch, just a single tree, once every hour. And here we changed it again. We have one big ever-growing tree where we just pick landmarks. And you're completely right. You can get a certificate immediately. I mean, certificate is added, CA signs the tree. Every second, the CA can sign a new tree, or even faster if it wants, but I mean, every second is fine. So you can get a certificate immediately. But that certificate, we call it a standalone certificate.
Right.
It needs the signatures, right? There's not a landmark for it yet, so it can't use the size optimization. So it's larger, right? But I mean...
And we're going to be able to have both a standmark or a landmark certificate, correct? They're both options.
Yes, so you will always want to have a standalone certificate on your server, right. But you can then also have a landmark certificate next to it. Actually, you can use the same one. So what you can do is you can provision the standalone certificate, and then you wait a bit, and then you replace that certificate with a different authentication path which goes to a landmark. So
and just to make sure, for the sake of the listeners, explain the benefit of a landmark.
So the advantage of the landmark is that you don't need the signatures. The landmark has already been verified out of bound. So if a client sees a authentication path to a landmark, it's like, this is fine. I don't need to check anymore.
Gotcha.
So
Bas, this is great.
It's more performative.
Yes, it's much smaller. Yeah. It's like it will be about this. So a PQ certificate with MTC will be about the same size as a classical certificate today. Yeah. I mean, I'm really
just by coincidence.
Sorry.
Just by coincidence, right? It just happens.
I mean, this is what we want, right? I mean, that's the selling point. That's the selling point. This is what we want. Yeah.
I think explaining the selling point is critical here, Bas. But this is what this podcast is really all about. Solving the large signature problem was problem number one. That's why we're doing this at all. Yeah. But there are some other advantages. There are some other selling points, not the least of which is the fact that the CT log is essentially now the thing itself, right? In other words, security is really part of the system. So explain that, and maybe, what are the other, side effect advantages we get from this?
So the certificate transparency ecosystem, it really depends on the at the moment on the charity of the people involved, where it's been it's hard to run, and there's actually no requirement for people to run any CT logs, right? So it's that's not good. So what this does is, now that we've learned that certificate transparency is valuable, this also changes the system so it's easier to run, right? And also it puts the cost at the right place.
And MTCs don't need independent CT anymore because the MTC is doing that, correct?
It still needs something like it, but you don't need the CT logs as you have them today anymore. Instead, you still have you need to have something like mirrors, where the biggest part of the work is done by the CA, which publishes their tree. It computes everything. It does the whole thing, but you don't have the separate CT log anymore. You will have people that have a similar role, which are like mirrors that mirror your CT log, which is much easier, right? It's just copying some files.
And so the CT, just again, not assuming that the listeners has already learned any of this, the MTC, the Merkle Tree log that the CA publishes that similarly to the way they publish to CT today, right? So those are there available where they can be grabbed by the mirrors. And that's part of, to be a public CA, you're required to maintain this publicly available Merkle Tree, correct?
Yeah, so what it used to be is you log what you issue, and what happens now is that you issue by logging, right? You log in your tree what you issue, and that the act of logging is the issuing. Yeah.
So, Bas, it's not a certificate in the traditional sense. You've just said it. When we think about certificates traditionally, or what's going on right now, of course, the CA sign a certificate signing request, and that's a cert. So what is essentially what we're calling a cert in MTC? What's the C in MTC? So obviously there's a hash function that has occurred on the tree. There is some other information that comes from co-signers. What is the cert?
Well, so because we explain Merkle Tree Certificates as we're doing things really different now, it sounds like it would be really different. But if you really look at it, a Merkle Tree Certificate, the thing you actually get in the end is not that different, right? So it's still an X509 thing. It's still ASN1, in contrast to the very first iteration. The ASN1 returned. So it's still an X509 certificate. There's two differences. The first difference is that the signature is not on the certificate body itself. Instead, the certificate body that is added to a Merkle tree, it gets this authentication path. It's this Merkle tree hashes. That's a bunch of hashes to show it's in the tree. And then the signature or signatures, it can be multiple or none at all, is on the root of that Merkle tree. So in a way, if the tree is, if you put it in a one thing tree, right, where it's just tree one thing, and you always create one signature, then it's exactly like an X509 certificate. Maybe a different OID, but it's exactly the same thing. So basically, it's a certificate that has more flexibility with which we can do much better logging on the CA side. Yeah.
Bas, I'm going to offer one more advantage, and you can verify or not, which is the fact that the thing that seems to be important now with an MTC is that the Merkle tree path, which is a set of hashes. I'm going to use your words from one of your previous visits with us here on this podcast, which is hashes are kind of resilient to post-quantum computing in the sense that quantum computers only give you a quadratic advantage, not a polynomial advantage, using your words from last time, right?
Not even quadratic.
Not even quadratic. So therefore, that is to me one of the smartest reasons for Merkle tree certificates is the fact that we're using cryptographic primitives that are inherently resilient to quantum computing. Any comments on that?
That's completely true, right? The Merkle tree bit of it. I mean, so there's no way no way. I mean, it can't be categorical, but no one expects quantum computers to do anything against hashes in any reasonable way. So that's like it's very solid. And actually, the we have now with SHA-256. That's actually 256 bits security with a. I mean, there's actually a little technical tweak we might need to do, but that's not the thing that will fail. We still need signatures though, right? In the end, the triad has to be signed by something, which is a post-quantum signature. So there's still signatures there, but the hashes bit, that's very solid.
Do you anticipate by the time this goes live and real, used in anger on the public internet, do you think it'll be MLDSA? Do you think something else? What do you suspect?
Oh, this is an interesting episode on its own. No, it's like if I'm reading the tea leaves now, I think the most common signature will be MLDSA 44. That's if I'm reading the tea leaves now. That's it's level 2. It's even above 128 bits. It's not quite 192 bits, but it seems like that's where people are heading now for the initial deployment. And
oh, that's great.
So, Bas, when I'm hearing all this, it all sounds neat and elegant. It also sounds like we're going to have to update every single bit of our connected software throughout our entire deeply digital life. What happens to the stuff that doesn't get updated?
Well, we have to do something for the PQ migration anyway, right? I mean, we need to add MLDSA, we need to implement MLDSA in all these places, or some kind of PQ signature anyway. So we need to do something anyway. On the client side, it's actually, maybe let's look at the different stakeholders and how much work it is for them. If you have a client, then and you don't care about the size that much, the size optimization, then the only thing you need to do is to be able to understand this new kind of certificate, and that's to be able to know what to do with the authentication path, which is, it's a code change, but it's not the most difficult thing, and probably your TLS library will do that for you. So that's one. On the server side, if you also don't care about offering performance, then you just install the standalone certificate. That's not different at all. If you do want the size benefit where you can negotiate a landmark, then on the server side, you need to be able to install 2 certificates. Not all servers are able to, but we will need to anyway. You need to do with PQ, right? Not all your clients can upgrade at the same time, right?
Right.
Not all our clients can upgrade. So you need a post-quantum and a classical certificate anyway.
So I try to connect with post-quantum. If I can't, I fall down to classical. Would that be the idea?
Yeah. So you need to be able to install 2 certificates anyway. So with MTC, you need to be able to install 3 certificates now, a standalone, a landmark relative, and a legacy one.
Right.
And the client needs to tell the server whether it's up to date enough. So it needs to understand the client saying, "Hey, I have this landmark." The server needs to understand which one to give back. So that's also a small code change. Well, small. Installing multiple certificates if you don't have a place. I mean, that can be a pain, but it's a pain we have to solve anyway. Although there's discussions of very ugly encodings where you put multiple certificates in what seems to be one certificate. But I mean, let's hope we won't need that. But these are on the table. The clients, if they want to take advantage of the landmark relative certificates, they need to be able to fetch the landmarks from somewhere, right? For browsers, they basically kind of have most of this already in place. And everyone else really doesn't, right, at the moment. But that's something that people have been, for some, it will be easier. Like if you have an integrated PKI, like Apple has this, Android has this, I think. I think Windows is also in a better place to put that. But on Linux, there's some early where people have the UPKI project to add revocation to where that kind of project might also be leveraged to get these landmarks to get the speed optimization. That's certainly a difference and something we have to figure out, like where do we put those landmarks, how to encode them, etc.
So it sounds like there's work to do, Bas.
Yes.
So, this seems to all be coming quite fast down the pipe, but there also seems to be a lot of work to do. So what's happening in the meantime? A lot of work is what I'm hearing.
Well, I think the first steps to get something is not that bad, right? So if you just want the standalone certificates, that's not that big of a change for the client, and that's not a big change for the server. And for the rest, the hard work is the work we had to do anyway with the installing multiple certificates. Maybe another thing maybe is a nice topic for a separate episode, which is certificate transparency is absolutely essential to prevent downgrades from PQ to non-PQ. I think that's a really interesting topic, which we should dive in.
Yeah, let's carve that out separately. I would like to discuss that, but we can make that its own compartment, I think. So, wow, yeah, Jay.
There's so much. It's such a rich topic. Bas, I only have one last question for this one, and then we can, move on to so many other topics. So we have standalone PQC certificates. We have landmark PQC certificates. We have our classic certificates, and they're going to be living side by side probably for a long time, right?
Probably forever, right?
Probably forever, which is a long time. Yes. So what do you think is the pragmatic use cases for having both of the landmark and the standalone? We know that the landmark is the smaller of the certificates, right? It's, as you say, very performant, but the same size as a classic, which is just a fantastic property of it. So so the audience understands, what is the pragmatic real world reasoning for having, for maybe wanting to have both at your web server as a subscriber of these certs?
Well, you need a standalone, because the landmark relative one, you can only use it if the client is able to fetch landmarks. If the client can't fetch landmarks, it can't use it, and not everyone can fetch them. So you need them for those clients that can't have it. Also, you need it for clients. If I closed my laptop, I went on a holiday, I came back, I opened my laptop hasn't fetched the landmarks yet. It needs to have something to be able to connect to a website. We tested this with our preliminary. So we're running already. Chrome supports a preliminary version of MTC, and we have it on a couple of thousand domains. And we see that it's required less than 1% of the cases. We still have some tweaking to do here, but it seems to be that at least in 99% of the cases, you don't need it. But you do. 1%. You can't.
You wouldn't want to lose 1% of your connectivity. That would be pretty disastrous. Yeah. Yeah.
So you need it. Oh, and you need it, of course, if you want to set up a website stat, right? You want people. There's whole businesses that work on. You want a website now, get it in 5 minutes, right?
Right.
If you have to wait 2 days before your website is up, that kills businesses. Yeah. So
that's awesome. That's all, Tim. I think
this is a great place to leave it, Bas. We are going to have you back for sure, and we're all going to be wearing our exact same shirts. And so I look forward to speaking to you again soon.
Thanks, Bas.